It's worth thinking through this carefully and playing a bit of devil's advocate at this stage. Is there a situation where the solution that we just found is not good? Can it be too conservative? To answer this, let us consider an example. Suppose a brilliant but lesser known chef opens up a new restaurant. Everyone who goes to the restaurant raves about it, and in few weeks it gets 4 reviews, few genuine 4 reviews on Yelp, which are all 5 stars. In this case, the above correction would suggest that the score of this restaurant should be, well, 5, which is the average, minus correction, which is 2.5 divided by square root of number of samples, here it being 4. So it turns out to be, if you did the calculation, 3.75. Well, this would mean that when we order restaurants by this adjusted score, this new restaurant is potentially unlikely to show up in even top 10 restaurants, because there will be many veteran restaurants with average score of 4. Will this prevent this restaurant from ever becoming a top restaurant on Yelp? Not really, since hopefully over time enough people would visit the restaurant, and then this will naturally bring it to the top because correction would become smaller and smaller. On the other hand, our conservative correction will prevent it to be discovered early on by various Yelp users, and this would make it longer for this restaurant to become popular. So this suggests that our conservative correction is preventing some kind of exploration among users early on. If we wanted to encourage some form of exploration, then we should do optimistic correction rather than the conservative correction. That is, the adjusted score should be average rating plus, not minus, plus constant divided by square root of number of reviews. Is that it? Are there other corrections that can benefit scores of restaurant at the population level? Well, for one, the freshness of ratings or reviews is important. This is especially important in the context of restaurant. As time progresses, the restaurant can become better or worse depending on many factors, including changes in chef, management, or whatnot. Therefore, it may make sense to put more weight on recent restaurant ratings compared to those further in past. So how do we account for this? In computing average rating, we shall assign weights to the ratings. You see, before we assigned uniform weight to each review or rating, but now we can assign weight to each review or rating depending upon its age. For example, if we think of half-life, remember half-life the way we think of in nuclear physics? Let's think of a half-life of a restaurant as 3 months. That is, this is the time scale at which changes in restaurant become relevant. Then we can define normalized age of a review as actual age of review divided by 3 months. So for example, if the restaurant had a rating 12 months back, then the normalized age would be 4. And then the weight of the review would be exponential of minus 4. It says that as age increases, the weight decreases. Now the new weighted average score would be computed as follows. Weight of review 1 multiplied by the score of review 1 plus weight of review 2 multiplied by score of review 2 divided by weight of review 1 plus weight of review 2 . Okay. Again, remember previously weights were uniform, that is equal to 1. Now we are going to change them. And correction in this average score would be given by, as before, a constant divided by square root, but not square root of just number of samples, but a weighted sum of the reviews. That is weight of review 1 plus weight of review 2 . There's a small twist. We will also divide this number by the maximum of the weights among all n reviews. Again, if you remember, when weights of all reviews were equal in the earlier setting, this would be nothing but square root of number of samples. In summary, in this section we learned the following. The average rating or score is an excellent proxy of the restaurant's true score. That is, we learned the algorithm of population averages. Now, due to limited number of reviews or ratings, in the context of restaurant, it needed an adjustment. Conservative adjustment suggests reducing rating depending upon the number of reviews. fewer reviews leading to more reduction, more reviews leading to smaller reduction. Optimistic adjustment suggests increasing rating depending upon the number of reviews, with fewer reviews leading to more increase. The freshness of rating is very important to take into account. Weigh recent ratings more compared to older ratings. So this is the end of section on how to use population averages. In the next section, we're going to understand how to use population averages when data is in form of comparisons. Thank you.